scientific philosophy that they did. So check this clip out. It's in response to somebody interviewing him and saying, can you give an example of a genetic mutation or an evolutionary process which can be seen to increase the information in the genome? So the answer is no. So listen to how he says this, tries to get around this here. He tries to tell us that we have to believe that species change into other species.
There's a popular misunderstanding of evolution which says that fish turned into reptiles and reptiles turned into mammals, and so somehow we ought to be able to look around the world today and look at our ancestors. We ought to be able to see the intermediates between fish and reptiles, and between reptiles and mammals. We ought to be able to see fish kind of on the way to becoming reptiles. But of course that's not the way it is at all. Fish...
Did you hear that? Right there. You can't see it.
Reptiles, and between reptiles and mammals. We ought to be able to see fish kind of on the way to becoming reptiles. But of course that's not the way it is at all. Fish are modern animals. They're just as modern as we are. They're descended from ancestors, which we're descended from. Way back 300 million years ago, there would have been an ancestor, which was the ancestor of modern fish and the ancestor of modern humans. And that ancestor, if you could have been there then, you could have seen the first steps towards a fish, say, coming out onto the land and becoming something like an amphibian. But that was a long time ago. You wouldn't expect to see that today.
Right there. That's it. You can't see it. It's invisible. It's pseudoscience.
And so quite a lot of the misunderstanding of evolution, I suppose, stems from the fact that people are looking at modern animals and thinking that Darwin has said we're descended from them. Well, we're not. We're not descended from modern fish. We're not descended from modern monkeys. We're not descended from modern apes. They are modern animals just as we are. They're our cousins. They're not our ancestors.
See, he says that it's a misunderstanding of evolution that people think that we should see the co-cestors or the stages between the species. And because it's so, there are some fossils that people point out that look like very roughly like intermediates between species. It's a stretch in a lot of the cases, and I'm not going to discuss that today. I want to steer clear of that debate issue. What I have to say here today is much more powerful against evolution. But here Dawkins, his nice way of saying, hey, I'm telling you there's visible pseudoscience called species changing into other species. He nicely calls that a misunderstanding people have, that we think we should be able to see that, or that we even think we should have a need to. So getting back to Miller's, why I played this quote from Richard Dawkins, the basic idea is that there's an assumption of this progression through time of the species changing, and that leads to circular reasoning. And a lot of people are going to say, well, isn't it? If there's one thing that people believe, is that that's what the fossil record tells us, that the strata at the bottom have the little simple creatures, and the ones at the top have the complex creatures. Now that's been observed, but it is not. Oh, just wait till you hear what we have to say about that. I can give you a summary. When Mount St. Helens erupted, it formed a canyon. Well, this is like a mini Grand Canyon, which had strata and formed such sediment layers where the little stuff sank to the bottom and the larger stuff stayed at the top. Like plants and so forth went to the bottom. Even formed a petrified forest that I've seen around the world that people have attributed to being millions of years old. One's forming there now, so it's quite... yeah, so we'll get there. But back to the circular reasoning issue. So it's very, very simple, but so simple I think many people have a difficult time wrapping their heads around this, because we've all been taught since we were very, very young that there's been a progression through deep time, and it's really hard to undo certain thoughts that you've been indoctrinated with since you were very, very young. That's the purpose, of course, of our public schools, to get a lot of these erroneous thoughts in our mind, that war is inevitable, or that there's deep time and a proliferation of species through time, and all this kind of stuff. All these non-verifiable, unempirical, non-scientific accounts. And if you speak up in class back then and say, excuse me, teacher, can you show me some evidence that war is inevitable? The teacher, you'll probably just get sent to the principal's office. Of course, that's not literally what will happen, but you'll probably be deemed as some sort of a troublemaker. So let's move on then and get into this correct reasoning, get out of the circular reasoning, and get into the logical reasoning, the non-contradictory reasoning, and the empirical science behind the anti-evolutionist accounts. And the evidence is staggering, huge, copious. There's so much that I had trouble keeping this show into 2 hours. I'm sure it'll go to 2:15 to 2.5. Okay, I've been planning on about a 2-hour talk, but there's just so much to cover. It's unbelievable, and it's all data points for the anti-evolutionist account, and picking apart their wild philosophies that they have, such as natural selection producing evolution and so forth, rather than punctuated equilibrium. So anyway, let's get moving here. Let me try to give you a summary of my argument in the simplest terms, and then I'll say it a little bit more complexly, and then we'll get into the big, meaty details and hit the scientific journals and the whole deal. Now, if you look around at the world, animals and humans use DNA as their codes. Well, there's many different ideas of what DNA is, of course, but one thing that let's focus on, which the academics focus on, is DNA is the code for composing the structure of our organisms. They dictate our morphology, is a better way to put it. Now, similar features show up in similar creatures, so therefore there should be repetition among, in the correlation between DNA code structure and the morphology. So I don't know enough about it from genetics, but from what little I know, the way it should work is if you've got a gene to have 5 digits on your hand, that your genetic structure will dictate that, and there'll be a common pattern to at least a degree from you and any other 5-digit creature. What does a raccoon have 5 digits? Who has 5? Primates, of course, do. But anyways, there's all these similarities of morphology, and there's all these similarities of DNA. And when we look at the creatures of the world, basically it looks like this. We all have this DNA code in us, and the same sequences show up from creature to creature to creature. Some creatures have more of the same sequences showing up as compared to other creatures, and then some creatures have fewer similarities of the sequences and codes and patterns of the DNA as other creatures. It just depends, how many similarities or differences you have compared to other creatures. Now, this is the most rudimentary way of looking empirically at what is observed about the world. It's as if we find ourselves here in this world, and there's these creatures with all these different codes, the patterns and sequences of which are shared in many, many ways, and then there's, of course, differences between them as well, but all these commonalities between them, as if the DNA codes are just different mixtures and so forth, different ways to create different creatures. So the same pieces and sequences and codes and so forth are used to create different creatures. Now, you have to be more or less similar to all of them. So our morphology is much, much different from ourselves as humans to a stinging nettle plant, for example. So therefore, our structure will appear to be much more different than our structure is than from, say, a squirrel or a chimpanzee. All right. Now, what we should note, though, is the shocking similarities. As we've discussed, I think it was hour 2 last week, we discussed how hemoglobin and chlorophyll's kind of whatever, those two molecules are so stunningly similar that I don't know what evolutionists can say about that. It doesn't make any sense that they're so similar. So does that imply we have a common ancestor, or as Richard Dawkins would say, a co-cestor with the plants way back? And that's why chlorophyll and hemoglobin, human blood, is so similar? When I talk about hemoglobin, I'm specifically referring to the heme groups with an iron ion at the center. Anyway, I'm going to have a whole show on this later this week or next week or something, and I'm still letting this season in my mind, but I'll just say this: that shows conclusions that could be so stunning that just this similarity of chlorophyll and hemoglobin alone could take down all of evolutionary theory. But we'll discuss that later. Let me get back to my introduction on this attack here of fusion, chromosome 2 fusion. Actually, this is a good place for a break. Let's take a break right there. This is the Antimatter Radio Show. I'm Jeffrey Grupp, talking to you today about the end of evolutionary theory. We'll be right back and continue exactly where we just